All right, this video is here to help your growth and decay project. First, it's about zombies roaming the area. So we've got this great story about zombies attacking this virus, this giant word that is fun to try to say. And here's our story with it. It's been said that the virus started from 200 people actually swallowing their iPhones. From there, it is growing at a rate of 15%. It started in Cincinnati, Ohio, and is set to start spreading worldwide if we can't get other cities ahead of it. Now, as I'm reading this, I am thinking about this underneath part 2, where it says type in your equation below. I got to write my growth factor or my exponential growth equation. That equation looks like y equals a times b to the x power. A is your starting amount, B is your growth factor, and X is your exponent. For right now, we're going to skip part 1 because that's something you should easily be able to do, just Googling the population of these cities. We're going to look at parts 2 and 3. So for part 2, I've got to write my equation. Well, the starting amount, it looks like 200 people says it started with the infection. Okay, so I know that's going to be my starting value, my A. And then my rate says 15%. Well, in order to help that with my growth rate, I've got to change that. I got to do 1 plus that percent. So I know it's going to be y equals A, which is 200, times whatever my B value is. Now, for my B value, it says 1 plus the percent. Well, my percent of 15, I need to change that to a decimal. So most things, when you hit 15%, it'll change them. Whoop, I guess this calculator. It'll change it to a decimal. Another way to do it is to move the decimal 2 to the left or divide it by 100. If I divide it by 100 or move the decimal, I get 0.15 as my decimal. So now in order to get my growth factor, I've got to do 1 plus that 0.5. So I'm going to do that plus 1, and that gets me a growth factor of 1.15. Exponential growth factors are typically over 1. From there, I'm just going to write to the x power as a helper. That exponent is going to change many times. When I look at part 2's instruction, it says how many days until the cities are overcome. So it says when the zombie amount overtakes the population amount, the exponents will be the number of days. So now that I've got my exponent question, I've got to go back and look at my populations. Let's just say, for example, this is not the right answer. For example, 100,000 people live in Cincinnati. That is not correct. Just example, people. What I'm going to do is I'm going to go to a calculator and I'm going to type in my equation, 200 times 1.15, and I'm going to change my exponents to try to make it closest to 100,000. So I'm going to try 10 initially. I'm just guessing numbers. My answer is not over 100,000. It's 809. Too small. How about 20? 3,273. Too small. 30. 13,242. Still too small. 40. 53,572. Too small. 50. 216,000. So I'm over it, but I want to get closer. When does it overtake? What day? So it's got to be somewhere in between 40 and 50. So I'm going to start counting up. 41. No, that's 62,000. 42. 70,000. 43. Still not big enough. 44. Oh, it's close. 93,000. So it's probably this next one. 45. So for this hypothetical example here, 45 days would be how many days it would take to overtake the population of Cincinnati. How many outbreaks? So what I would do is I would go back to part 2. For the number of days for Cincinnati, I would write my exponent, 45. Because that's when I plugged in this equation. I used this as my x value. It was greater than part A, or part 1's population. Okay? All right, remember, those are not the actual answers, so you're going to have to find those answers yourself. The next piece is part 3. It says, we stopped the zombies, hooray! And now there are decaying corpses everywhere. Gross. There are 50 million zombie corpses, and there are decaying at a rate of 20% per day. How many days will it take for all of them to turn into wonderful compost? Or at least to turn into compost. That's good. So I've got to do another equation here. It's got my decay factor, and this helps me out. This is the same kind of deal. The only difference in a growth equation and a decay equation is that your decay factor needs to be less than 1. Okay? I'm actually going to just write that over to the side. B needs to be less than 1. So the way I'm going to do this is I've got to get my starting amount. Well, what's the starting amount here? Well, my starting amount is 50 million. Holy moly, that's a lot of dead zombies. And I got to multiply that by the decay factor. Well, the decay factor says it's 1 minus the percent as a decimal. So now I got to do 1 minus the percent as a decimal. So I'm going to do 20 divided by 100 to change it to a decimal. And I'm going to do 1 minus 0.2. That gets me 0.8 is my decay factor. So my decay factor is multiplying this by 0.8. And then it's going to go to whatever x power. Once I have that, I'll go back to my calculator, 50 million times 0.8, and then I'm just going to start typing in numbers to see when it's going to reach 0. How about 20? Okay, 20, we're still not at 0. I've got to go until my number would reach 0. When this number right here reaches 0. That's what I've got to do. When I find that number of days, I will put this exponent in here for number of days. Hopefully this helps you out. If you've got a question, feel free to email me. It's right up here, 2ea@masonohioschools.com. Good luck, and don't save the zombies. Save us, and get this turned in by Monday.